A very good morning to all of you. Once again, I welcome all of you in today's practical. Now, in the today's practical, we are going to see the practical, that is practical number 8, which is on selection of charts for selection of pump. Okay, so I am going to share today's practical content with all of you. So basically, we have one. So something will be wrong with share option. Now screen is visible. Yes. Hello. Screen is visible to all of you.
Yes, sir.
Okay. So under the hydraulic engineering laboratory second, if you see whatever may be the practical we have covered up till now. So under group A, we have completed this first practical, that is calibration of V notch or the rectangular notch. Okay. So in case of the V notch, that is a triangular notch, we have calculated their discharge through the channel. Okay, so we have the formula to calculate the discharge through the channel by triangular notch, that is 8 by 15 CD tan theta by 2 root 2 G H raised to 5 by 2. Then we also completed the second practical, that is calibration of Ogilvy. So wear or notch is a arrangement which is made across the channel, okay, across the flow in the channel to measure the discharge. So the first and second practical is uh, for determination of discharge through the channel. So these are the two arrangements by which we can measure the discharge through the channel. Okay. So in case of the Ogilvy, we have the formula for the discharge, that is 2/3 CD into L into root 2G H raised to 3 by 2. Okay. Now we also completed this third practical. So as far as concerned with the third practical, that is study of hydraulic jump, in this practical we have calculated the different parameter of the hydraulic jump. And also we have seen that the locations of hydraulic jump where it is formed and why it is need to be studied. So in the study of hydraulic jump, we have calculated the sequent depth, then loss of energy due to the formation of hydraulic jump. Then also we have calculated the Froude's number, Fe, which is equal to V upon under root GD. Then also we have calculated the length of the jump, height of jump, that is Hj, and the ratio of depth Y2 by Y1 and the energy loss. Then we also perform this practical study of flow below gate, that is the discharge versus head relation. So in this particular practical, we were calculated the total energy H plus V square by 2G, then critical velocity, critical depth and minimum specific energy. Now as far as concerned with the fifth practical under group A, that is the velocity distribution in open channel in transverse direction of flow. So as far as concerned with this fifth practical, we were seen that how the velocity will be distributed across the channel when the water is flowing through the channel. So as far as concerned with the velocity distribution in open channel, we were seen that where is the maximum velocity will occur and how the velocity will varies according to the depth. Now if you consider the depth on x-axis and the velocity on y-axis, and if you sketch the graph in between the depth versus the velocity, then in that case we will find out the point where the maximum velocity will be occur. So as far as concerned with the open channel flow, the maximum velocity will occur at the bottom of the channel, that is at the bed, and at the free water surface the velocity is minimum. So how the velocity will varies, we also seen with the help of velocity distribution diagram. Then we have the group second of fluid mechanics 2, that is the hydraulics engineering laboratory 2, that is the impact of jet. Okay, so this is the sixth practical, and under group B, first practical, that is the impact of jet. So in case of the impact of jet, we were seen that how the force will exert when the water is come out through the jet which is connected at the end of the pipe. So when the jet is coming out through the nozzle, the force impacted by the jet of water on a particular surface, the surface may be the either vertical surface, the surface may be the either incline, the surface may be curved surface. Then in case of the curved surface, the jet will strike at the center and the plate is symmetrical. Then jet will strike from one end and the plate is symmetrical, and jet will strike at one end and the plate is unsymmetrical. So for the stationary as well as for the movable, that is the moving surface, we have seen that how the force is exerted on a particular surface. Okay. Then we also determine the efficiency for the turbines. So there are three types of the turbines. The first one is Pelton wheel turbine, then Francis turbine and the Kaplan turbine. So in case of the turbines, we have determined the efficiency of a turbines. Okay. So eta is equal to output power divided by input power into 100. So with the help of that, we can determine the efficiency for any one of the turbines. Then in the last practical, we also completed this seventh practical. Okay, that is the eighth practical. This is the eighth one, and under group B, this is the third practical, that is the test on centrifugal pump. In case of the centrifugal pump, what is centrifugal pump, what are the various component parts, we also seen that, and we also perform the practical on determination of efficiency of a centrifugal pump in the last practical. So as far as concerned with the centrifugal pump, it is a hydraulic machine which convert mechanical energy into hydraulic energy. Then we called it as a centrifugal pump. So how the centrifugal pump work, we also seen that. Component parts also we have seen that. Okay, and how to determine the efficiency of centrifugal pump, we also seen that by demonstration, that is the practical experiment. Now this is the 8 practical we were completed throughout this particular semester, and this is the last practical, that is the study of chart for selection of pump. Okay, now in the today's practical we are going to study the chart for selection of pump. Okay, so pump is a hydraulic machine which convert mechanical energy into the hydraulic energy, that is the pressure energy, by means of centrifugal action. Then we called it as a centrifugal pump. Okay, now what are the various purpose of the pump? What are the various purpose of the pump? Where we can install the pump and why it is installed pump? Okay, that is the question in front of us. So can anybody tell me what is the purpose of pump? What is the main purpose of pump? Anyone? Unmute yourself and tell me. Yes? Anyone?
To lift the water.
Yes?
To lift the water.
Okay, to lift the water. That is the correct answer, but you need to improve the words. Okay, you need to improve the sentence. That is the insufficient sentence, to lift the water. That is correct one, but we need to enlarge it. To lift the water from lower elevation to the higher elevation. That is the correct definition of the purpose or the objective of pump. Okay, to lift the water from lower elevation to the higher elevation, then we called it as a pump. Okay, now if you justify this definition, you can take example of the well setup. Okay, शेतामधली जर विहीर बघितली तुम्ही, ज्याच्याकडे शेत असेल त्याला माहीत असेल हे सगळं, आणि सगळ्यांना माहीतच आहे, वी हॅव ए वेल सेटअप. ओके, आणि विहीरमध्ये तिथं 8 परस विहीर असती, 5, 10. ओके, आणि त्याच्यामध्ये पाण्याची डेप्थ असते, म्हणजे 2 परस किंवा 5 परस, डिपेंडिंग अपॉन दी वॉटर टेबल. ओके, आणि जर आपल्याला इरिगेशनसाठी पंप यूज करायचा आहे, okay, as far as concerned with the engineering point of view, okay, if you want to select the pump for the irrigation purpose, म्हणजे आपल्याला पिकांसाठी पाणी द्यायचं आहे. समजा वन फार्मर इज हॅव्हिंग 5 एकर फील्ड, एका शेतकऱ्याकडे 5 एकर शेती आहे, आणि त्या 5 एकरामध्ये त्यांनी असं मॅनेज केलं की फॉर 1 एकर 1 एकरामध्ये ऊस घ्यायचा आहे, शुगर केन. नंतर इन सम एरिया that is for the 1 acre jawar. Okay, jawar crops, then the vegetables also. So that farmer have the plan to take the different crops in the 5 acre field. Okay, now it is very important for us. Okay, it is very important for us selection of the pump. ओके, आता आपण काय केलं, मुद्दा मराठीमध्ये तुम्हाला समजण्यासाठी डिस्कस करतो. डायरेक्टर सरांनी सांगितलं मराठीमध्ये तर बोलू नका, पण तुम्हाला थोडंसं सांगतो. समजा आपल्याला 5 एकरमध्ये 1 एकरमध्ये आपण ऊस लावला, नंतर दुसऱ्या 1 एकरमध्ये, समजा दुसऱ्या 1 एकरमध्ये आपण व्हेजिटेबल लावलं समजा, ओके, 2 एकर झाले. 3rd एकरमध्ये आपण समजा जवार लावला पूर्ण, 3 एकर झाले, ऊस, व्हेजिटेबल, जवार, आणि 2 एकर उरले. आता 2 एकर मधून आपण समजा ग्राउंडनट टाकले 1 एकरामध्ये, आणि मग 1 एकर आपण तसंच ठेवलं, समजा कोरडा ठेवला. 4 एकरमध्ये आपण प्लॅन केलं की हे पीक आपल्याला घ्यायचे. आता आपल्याला हे पीक घेण्याच्या अगोदर, ओके, आपल्याला प्लॅन करावं लागतं. म्हणजे शेतकऱ्याला प्लॅन करावं लागतं की विहिरीमध्ये किती पाणी आहे, आणि 4 एकरमध्ये जर आपल्याला हे डिफरंट क्रॉप घ्यायचे असेल, ओके, जसं शुगर केन आहे, दुसरं आपल्याला पीक घ्यायचं आहे व्हेजिटेबल्स, ग्राउंडनट आणि जवार. तर मग शुगर केनसाठी हा पेरिनियल क्रॉप आहे, म्हणजे 12 क्रॉप आहे. व्हेजिटेबल 4 मंथली 8 मंथली असतात. जवार 4 महिन्यासाठी असती किंवा 3.5 महिन्यासाठी जवारचं क्रॉप असतो, आणि ग्राउंडनट हे 3-4 महिन्यासाठी असतं. मग यांना पाणी किती लागणार आहे, बरोबर, आणि तितकं पाणी आपल्या विहिरीमध्ये आहे का, हे माहिती करणं आवश्यक आहे. आणि दुसरी गोष्ट आहे की आपल्या विहिरीमध्ये इतकं पाणी आहे की आपण शुगर केनसाठी देऊ शकतो, व्हेजिटेबलसाठी देऊ शकतो, जवारसाठी देऊ शकतो, आणि ग्राउंडनटसाठी पण देऊ शकतो. इतकं पाणी आहे. आता दुसरी गोष्ट आपल्याला ध्यानात ठेवावी लागते, ती आहे की सिलेक्शन ऑफ पंप. म्हणजे किती HP पंप आपण मार्केटमधून परचेस करावा. मार्केटमध्ये 5 HP पंप आहे, 10 HP आहे, 15 HP आहे, भरपूर असे HP पंप आहे, हॉर्स पॉवर. मग कोणतं पंप आपण मार्केटमधून परचेस करू नये. नाव माय क्वेश्चन इज दॅट फॉर ऑल ऑफ यू, तुमचं काय याच्यावरती आन्सर आहे की विच पॉइंट वी हॅव टू कीप इन आवर माइंड व्हाईल परचेसिंग द पंप फ्रॉम द मार्केट. तुम्हाला सगळं मी कल्पना करून दिली की 5 एकरमध्ये 5 एकर आहे, 4 एकरमध्ये आपल्याला इरिगेशन करायचं आहे. तर मग तुम्ही पंपचं सिलेक्शन कसं करणार आहे. कोणी सांगू शकतो अनम्यूट करून, मराठीमध्ये सुद्धा सांगू शकता. मुद्दाम तुम्हाला मराठीमध्ये थोडासा डिस्कशन समजण्यासाठी लावलं, कारण मराठी ही आपली भाषा आहे, दिस इज द लँग्वेज, तो तुम्हाला चांगलं समजू शकतो. एनीबडी अनम्यूट युअर सेल्फ अँड हॅव ए लिटिल बिट डिस्कशन ऑन द सिलेक्शन ऑफ पंप. सांगा, लवकर सांगायचं. अनम्यूट युअर सेल्फ अँड टेल मी की पंप आपल्याला मार्केटमधून परचेस करायचं. हां, बोला.
Sir, we will firstly try to know the depth of the well, so how far it will be filled with natural water, and according to that we also can select the pump.
हे बघा, see here, this is very important things you should keep in your mind, okay, because we are the engineer, okay, and if you want to supply the water for irrigation purpose, okay, if you want to supply the water for irrigation purpose, I will discuss this with the you can say with the notepad, okay, so you can learn more. So I am going to on the notepad and I will write something, so you can better understand how you can select the pump and what are the various category of the pump which is available. I will discuss with all of you. So I will take 1 to 2 minutes to on the notepad. Okay, this is very interesting because if you want to supply the water for irrigation purpose, okay, so as a civil engineer, your responsibility is that depending upon the crop water demand. So sugarcane is having its own crop water requirement, then groundnut is also having its own crop water requirement. Each and every crops is having its own crop water requirement. Okay, first let us see the crop water requirement. Then we have to see also the depth of water inside the well, and once we have this particular data, then we can easily find out the how much water we require to irrigate the sugarcane, how much water we require to irrigate the groundnut. Okay, so such kind of knowledge we required. So I am going to on this notepad. Okay, so as to you can learn more with respect to this. So see here, for example, well setup we have a well setup. Then the depth of water will be there, 2 or 3 plus you can say, means yes, now it is okay. So here I am going to add another page so as to you can learn more with respect to this practical. Okay, this is very important practical as per your, yes, now it is okay. Slide is visible to all of you, yes? Slide is visible, slide visible आएगा? Yes, slide is visible.
Yes, sir. Yes, sir.
Okay, so here we have the AM of AM for the today's practical. Okay, so I am going to take the, okay, so the AM of today's practical. What is happening? Okay. So the AM is, okay, the AM is chart for charts for selection of pump, charts for selection of pump. So here if you see the pump, we have two pumps. Okay, we have two types of pump. One is centrifugal pump, okay, and another is second one is reciprocating pump, reciprocating pump. Reciprocating pump. Now another different kinds of the pump will be there. Submersible pump. Submersible pump is also available. Okay, submersible pump is also available. So as far as concerned with the centrifugal pump, or the definition is same throughout the pump, that is it is a hydraulic machine which convert mechanical energy into uh, hydraulic energy. Okay, so mechanical energy converts into hydraulic energy. Okay, into hydraulic energy. Now our question is that, for example, one farmer is having a well setup. So I am going to draw here the well setup. Okay, the farmer is having a well setup with 5-acre field. Okay, so farmer is having a well setup. So here we have a well, and inside this well, this is the depth of water. Okay, so this is the well setup. Okay, and this is the free water surface. Now the farmer is having the area to be irrigated. So here the farmer is having the field like this, 5-acre. This is the field, 5-acre. Okay, 5-acre field is there. Now the farmer is having the plan. Okay, the farmer is having the plan for the 1 acre. For this first plot, he has the plan to sow the crop, that is the sugar cane. In the second plot, groundnut. Then in the third plot, he is having the plan to take a jawar. Okay, in the, you can say, the third plot, he has the plan to take jawar. Okay, so here we have the crop, that is the jawar. Then we have the fourth, that is vegetables. And the fifth plot is empty. Okay, now we have a well set up. This is well. Now we have to keep a pump here. So we have to install a pump. Now at the bottom of this pipe, we have a footwall with strainer. Okay, footwall with a strainer, and inside the well we have to keep a pump position. So this is a pump motor. Okay, this is a pump motor. Now again we have another pipe, that is known as the suction pipe. Okay, this is a suction pipe, and we have to deliver the water at the, this is a delivery pipe. Okay, and we have to deliver the water at the ground. Okay, so now if you see here, this is delivery pipe. Okay, this is delivery pipe. Now this is a pump position. We have the pump. Then this pipe is suction pipe. This pipe is a suction pipe. So this is a setup we require to irrigate 4-acre field. Now, to irrigate this 4-acre field, the area to be irrigated. First, we have to understand the area to be. First, we need to understand the area to be irrigated. Something will be okay. So the first you can say the parameter we required, that is area to be irrigated. So area to be irrigated, So we have to calculate the area first. So in this case we have to irrigate 5-acre area. So we have to irrigate 5-acre area. Then to irrigate the 5-acre area, we require the discharge, that is rate of flow. So how much water we require? That is the question mark. To irrigate 5-acre, how much water we require? Now, for that purpose, which data we have to collect from the well setup? So we have to collect certain data, that is depth of water in the well. Okay. So we have to collect this data, the depth of water in meter in the well. Now we have to collect the another data, that is this is known as HS, suction head, and from the delivery pipe this is known as delivery head, and from the ground up to the depth in the well, this height we called it as a total head, that is capital H. So suction head plus delivery head is the total head. So what should be the total head? We have to calculate first, and depending upon the net suction pressure head required, that is NSPHR, net suction positive head required, we have to calculate, and depending upon this net suction positive head, means this head, total head, we have a chart. Okay, on this particular chart, on the x-axis we have the discharge in liter per second, and on y-axis we have the depth. Okay, so for example, for the depth or the total head, that is H, for example, the total head is 18.2 meter. So this chart will help us to exactly calculation for the purpose of discharge. म्हणजे 8.2 मीटर हाईट आहे, तर त्याच्यासाठी किती डिस्चार्ज आपल्याला येऊ शकतं लिटर पर सेकंड मध्ये, तर आपल्याकडे एक चार्ट आहे, त्या चार्टने आपण ते काढू शकतो. सो वन्स वी हॅव द एच, तर हा आपल्याला विहिरीमधला हा एच तिथून मेजर करावा लागेल किंवा शेतकऱ्याला विचारावं लागेल. Depth of water level in the well, this is the inventory data, this is known as inventory data. तिथून आपल्याला जाऊन फिजिकली ग्राउंड डेटा आहे, तिथं फिजिकली जाऊन आपल्याला हे डेटा कलेक्ट करावा लागेल वेल सेटअपचा, आणि मग आपल्याला मार्केटमधून किती HP चा पंप घेऊन यायचं त्याच्यावरती डिपेंड करतं. ओके. आणि मग आपल्याला शुगर केनसाठी किती पाणी द्यावं लागेल, ग्राउंडनटसाठी किती पाणी द्यावं लागेल, ज्वारसाठी किती पाणी द्यावं लागेल, व्हेजिटेबलसाठी किती पाणी द्यावं लागेल. आता ज्वारसाठी प्रत्येक 7 किंवा 8 डेजनी आपण त्याला पाणी देतो. आफ्टर एव्हरी 7 to 8 days इंटरवल वी हॅव टू सप्लाय दी वॉटर फॉर जवार. मग जवारचं जे बेस पिरियड आहे, म्हणजे जवारचं बेस पिरियड म्हणजे काय की जवार तिथं बी टाकल्याच्या नंतर त्याची कापणीपर्यंत किती टाइम लागतो त्याला आपण बेस पिरियड म्हणतो. आणि त्या बेस पिरियडमध्ये आपण किती इंटरवलनी पाणी देतो, किती नंबर ऑफ वॉटरिंग आपण देतो ते काढावं लागतं. अशाच प्रत्येक पिकाचं आपल्याला काढावं लागतं. आणि मग एका पाण्याची पाळीमध्ये किती पाणी आपण याला देऊ शकतो ते काढावं लागतं. हे सगळं डेटा कलेक्ट करून आपल्याला हा टोटल डिस्चार्ज काढावा लागतो. सो वन्स वी हॅव दॅट डेटा, okay, then we can calculate the total discharge required for sugarcane, groundnut, jawar and vegetable, and depending upon this discharge we have to select the pump. Okay, so this is a small introduction part how to select the pump for the different crops and how to calculate the discharge. Okay, now I am going to introduce with you one video so you can understand a better way how to select the pump for the supplying the water for the crops. Not even for crops, if you want to supply the water for the domestic as well as industrial purpose also, we require the pump. Okay, so what is a centrifugal pump? The main component part, how does the pump work, impeller type, drawing symbol, then net positive suction pressure head, then what is cavitation, why the cavitation will occur, what is the causes of cavitation, where are they used. Okay, so these are the main things we need to understand. Okay, so what is a centrifugal pump? So it is a hydraulic machine which convert the mechanical energy into hydraulic energy, and due to the centrifugal action which create in the inside mechanism of the impeller. So here we have the centrifugal pump. Now look at the this is a suction pipe which is connected or which is inserted in the water in the well setup. Then we have the delivery pipe which deliver the required quantity of water at the ground, and here we have a motor. In this particular motor we have a coil. Okay, we have a router, then we have a shaft, this is a axle rod, then here we have a impeller. So impeller is the main part of a centrifugal pump, and along the impeller the backward curved vanes is also attached inside this impeller, and inside this casing, the outer cover we called it as a casing. Okay, so this is a casing. So the main component part, we have the suction pipe with footwall and strainer, then delivery pipe, impeller, backward curve vanes, shaft of the pump, motor. So these are the main component parts of a centrifugal pump. Now how does the centrifugal pump work? That is the another things. Then impeller types, we have different types of the impeller. Then we have the symbols to symbols is used to draw the various different component parts of a centrifugal pump. Then net, suction, positive pressure head, then cavitation and The pump is used for supplying water for irrigation. Pump is used to supply the water for domestic, industrial purpose, and even for the wastewater purpose also. So these are the uses of the centrifugal pump. Okay. Now I am going to play one video at this stage. Okay. So I am going to play that video so as to we can clear all the things how we can select the pump for the irrigation purpose. So we have the chart for the selection of the pump. Okay. So here we have that video. आता चार्टच्या सहाय्याने आपण पंप कसं सिलेक्ट करतो ते मी दाखवणार आहे तुम्हाला. Pump chart. Okay, how to select the pump for the irrigation purpose to supply the water from. So here we have the
pump curves to learn how to read them and what the different lines mean. After you've learned about pump performance curves and the part they play in pump selection, visit today's sponsor, statesupply.com.
So I am going to explain all these things. So we have the different types of the pump as I have discussed with you earlier, that is centrifugal pump, reciprocating pump, and the pump that is submersible pump. Okay. So here we have the pump chart. Okay. So here we have a centrifugal pump. This is a centrifugal pump. This is not a centrifugal, but this is a submersible pump. In case of the bore, okay, house bore, we can immerse this pump in the water. Now look at the chart. Here we have, for example, we have the discharge on the x-axis and the head or the height of water inside the well is on the y-axis. So as far as concerned with the 80-meter head, you will be get approximately 90 liter per second water. Okay. Then if you look at the another the curve here, so if the head, total head is 120, and if you see here the discharge is 95 liter per second. So as the capacity of the pump will increases, okay, you will be get the more discharge at the outlet. So this chart will help us how the discharge will varies. So here we have the head on y-axis and the flow rate on the x-axis. Okay. Now the quantity of water, that is the discharge on the x-axis and the head on the y-axis. Now look at the for the no pressure condition. Okay. For example, see here, this is very important. See, I will play another parts. See here. Now this is the first position, means the suction pipe is horizontal and the delivery pipe is horizontal. So this condition is called is the no pressure condition. So for the no pressure condition, you will be get the maximum flow rate. Okay. Now as the head will increases, if you keep the positions of the delivery pipe as a vertical, so let us see how the discharge will varies if the head will increases. Okay. How the discharges varies if the head will increases. So when the pipe is now vertical, delivery pipe is vertical, the pressure is maximum and the flow rate will be 0. So if the head is now 140, okay, so you will get a little bit, you can say the flow rate is changes according to the head. So the head plays an important role for the, you can say, to get the discharge at the outlet. So how the performance curve will be there, see here. Now we have the different component parts. Now see here, uh, in the back position of this particular video, see here, I will play a little bit previous. Okay. Now these are the main component parts. See here, we have the protective case, then we have the fan. Fan is required to cooling the starter, copper coils which is inside the casing. Then we have the electric motor, then we have the motor cover, then this is the router, and this is the shaft. Now this shaft is connected to the impeller, and on the periphery of the impeller, backward curve mains is connected. Okay, so these are the component parts. Okay, now if the pump will overheat, so what will be happening? Apan bolto na pump जळालं म्हणून. Now what will be happening? What is the main reason behind to burn the pump? To burn the inside mechanism, because if the height, total head will increases, जर समजा हा टोटल हेड इन्क्रीज झाला तर काय होईल, तिथं या पंप वरती प्रेशर येईल आणि प्रेशर आल्याच्या नंतर इथला जो कॉइल असतो तो ओव्हरहीट होऊन जाईल, and due to that the pump will burn. Okay, so this is how the problem will be there if the head will increase. So we often hear then in terms of the head or the meter. Okay, so why is pressure measured in lane? Okay, so look at here, we have the pump setup. This is the suction pressure and this is the delivery pipe. Now if you want to measure the pressure in the suction and delivery pipe, we have this two pressure gauge. Okay, so if you want to measure the pressure in the suction and delivery pipe and to maintain the pump in good working positions, then this is the a modern pressure gauge we have. Okay, so for example, the pump can provide 125 feet of water head, that is 13.18. Now if you compare the pressure, for example, in this first case the water is flowing with a specific gravity 1. Now if you see here, the pressure in case of the delivery pipe is 54.25 psi or 3.74 bar. Now psi into kg per centimeter square we have to convert it. And in another case, the milk, okay, the liquid is now milk is flowing, the specific gravity is now heavier than the water, because the milk is heavier than water and its specific gravity is little bit more than the water. Now here in this case, as the milk will flow in the another delivery pipe, the pressure is now will increases as the specific gravity is more. So this is we have to keep into consideration as far as the different kinds of, you can say. Then this is the conversion in terms of feet of head into meter, we have a conversion. Now according to the head, as the head will increases, the pressure on the pump will also increases. Okay, and due to which the friction will also created inside the water. And now to these things, what will be happening? The friction will develop, and due to the friction, what will be happening? The inside of the pipe will damage, and due to which we have to calculate the loss of head due to friction, that is by Darcy-Weisbach formula. So here, as we have seen here, this is known as the Darcy-Weisbach equation to calculate the loss of head. Okay, that is HF is equal to FL V square by 2GD. Okay, where HF is the head loss, V square is the velocity, F is the friction coefficient, G is the gravity, L is the length of the pipe, D is the diameter. Okay. Now here we have to remember that whenever there will be a friction, there will be a cavitation. Okay, otherwise the pump will be useless. Okay, so the pump will cannot deliver the required amount of the discharge. Okay, so for example, here if you want to supply the water, in case of the water geyser, hot water heating systems inside the industrial. Okay, so here how we can deliver the water and how we can get the discharge at the outlet as the head will increases. So this is the basic things we should understand depending upon the flow rate. So the quantity of water in given time frame. So for example, if you want to deliver the required the water with respect to the liter per second or meter cube per second, so and how much pressure will be there, so that depends upon the performance curve. So see here, this is the performance curve, as already we have seen in the beginning of this particular video. So as the head will increases and if the positions of the delivery pipe is 90 degree, so what is the you can say the performance, okay, of that pump. So this we called it as a performance curve. So sometime referred to as the HQ curve. This is a HQ curve. So on the x-axis this is the head, total head, and on x-axis we have the Q, that is flow rate. On y-axis we have the head. So this curve we called it as a HQ curve. So HQ curve will plays an important role for the performance of a centrifugal pump. So H means the total head and Q means the flow rate or the discharge. Okay, as the head will increases, there will be a pressure on the pump, you will get less discharge at the outlet. So we have to select the proportionate pump depending upon the HP. Okay, so such kind of performance curve we have to sketch. So see here, now as the pump height, as the delivery head will increases, now here delivery head is now little bit in case of the height. आता इथं बघितलं तर तुम्ही फक्त थोडंसं हाईट आहे डिलिव्हरी पाईपची, म्हणजे समजा 5 मीटर, तर यू विल बी गेट मॅक्झिमम डिस्चार्ज विथ. आता इथं बघा, इथं डिलिव्हरी पाईपची हाईट समजा कमी दिसते आपल्याला, त्याच्यामुळे तुम्हाला एक रिक्वायर्ड प्रेशरनी काय होईल, डिस्चार्ज भेटेल. यू विल बी गेट ए रिक्वायर्ड प्रेशर डिस्चार्ज ॲट द ग्राउंड लेवल. बट सी हियर, as the height of this curve will, head will increases. Okay, जर head increase झाला, so you will not get the required pressure at the outlet. So see here how the discharge will varies as the head will increases. So basically as a engineer, our responsibility is that we have to keep a proportionate suction head as well as delivery head. So you will be get the required discharge at the outlet in liter per second or in meter cube per second. So here, for example, the head is 1.8 meter, that is equal to 6 feet. So if the head is like this, you will be get how much discharge? 0.4 liter per second. Now if the head is 3 meter, that is the 10 feet, you will be get the 2 liter per second of the discharge. So as the head will different, you will be get different discharge. Now as long as our system requirement are on or below the performance line, the pump can be considered. So here we have a pump 1 and pump 2, and we have the head, different head. So here 21.3, so we will get 1.89 liter per second for the pump first. Now according to the size of the impeller also, so we have the different types of the impeller. So depending upon that, you will be get different head also or different discharge also. So here we have the impeller size. So 114.3 mm. So you will be get the little bit less discharge as compared to the maximum size impeller. So here we have a small size impeller. This is a closed impeller. Okay, we have the semi impeller also, or the open impeller also. So in case of the closed impeller, so different sizes we have as far as concerned with the closed impeller. So 165.1 mm, so you will be get a maximum discharge as the size of the impeller will increases, because it will suck the water from the well as much as possible with the capacity. As the sizes will increases, you will be get more discharge at the outlet. So this is how the performance of the pump will depend. So this practical is very important as far as concerned with the supplying water for the irrigation purpose. Okay. So if you want to do your project in case of final year also, or in case of your third year also, so you have to do the project, that is a physical project with relation to the ground observation. Okay, so it required the ground data also, physical data. Now here if you calculate the pump calculation, new impeller diameter, then we have the certain formulas. Now see here how the working of the centrifugal pump will be there. Okay, and how the pump will operate with the help of the different performance curve. Okay, so here we have the different you can say the power which is required to run the pump and to deliver the required amount of water for the required elevation or required height. So we have a 0.5 HP pump, 0.75, 1 HP, 1.5 HP. Okay, so for 1.5 HP, how much kilowatt power we require? That is 0.75 kilowatt power. Then what is the head on which the 1.5 HP pump will run, and how much discharge we will get exactly? If see here, if you use 1.75 HP, then we have the conversion factor kilowatt into watt. So this is the another chart, that is the efficiency. If you want to calculate the efficiency, output power divided by input power into 100, you will be get the efficiency of the pump. So with the help of this certain chart, we can compute the efficiency also. So today we will stop here. I hope you will understand all the curve to select a appropriate, you can see the pump. Okay, so if anybody is having any question right now, you can ask the question. Anyone is having any question? Yes,
No, sir.
Mangesh, Farzad, Sayyad, Nuruddin. I am going to download the attendance.
Hello, sir.
Nuruddin.
Hello, sir.
Ah,
No, sir.
yes, yes.
Sir, we have to provide water for irrigation. Okay. So will
Okay.
the at what distance we have to provide water? So it will matter while selecting the pump, sir.
So basically, that depend selection of pump means if you want to purchase the pump from market. Okay, so before that, as an engineer, we have to do the calculation like as already I have mentioned here. Okay, I will share that again so you can understand very well. So for example, if you want to select the pump from the market, okay, I am going to share this again. See here, okay. Now basically if you want to select the pump from the market, which observation we require before selecting the pump from the market? First, we have to plan according to the acre. For example, we have a 5-acre field. In the first acre, the farmer will have a plan to take a sugar cane. In the second acre, groundnut, jawar and vegetable. Then we have a crop water requirement and their base period. For example, for the jawar, the base period is 3.5 months or 4 months. So during the base period, how much water we have to supply? We have to calculate that. There is a standard procedure to calculation in case of water resources engineering. This will you can learn in 3rd year. Okay. So once we have that calculation, means the total discharge we required for the jawar, then total water which is required for vegetable. So once we have the total Q, okay, once we have the total Q, for example, the total Q is, for example, we required daily 5,000 or more than that liter per hour. Okay, so liter per hour. So this is the required demand for irrigation purpose in 1 hour. Now we have to do the well inventory. So this is known as the well inventory. This is known as the well inventory. Well inventory means what? We have to take a physical data from the farmer or by measuring the actual depth inside the well. This is the total depth of water. Then we have to also measure the total empty height inside the well also, and we have to calculate the total depth of well. So once we have this data from the ground observation, physical data, then we need to understand if we have this depth of well, okay, for example, this is the depth of well, then we have a selection chart. Each and every manufacturer may have the chart. म्हणजे प्रत्येक मॅन्युफॅक्चर जे पंप करतो, प्रत्येक कंपनी त्याचा एक स्टँडर्ड चार्ट असतो. समजा विहिरीमधला समजा इतकं हेड आहे, तर मग त्याच्यासाठी पंपचं डिस्चार्ज किती असणार आहे. As I have already mentioned here in this particular video, see here. For example, see here in this particular video, okay. Yes, now for example, this is the head and you will be get the rate of flow. Every manufacturer having this same chart. जेव्हा कोणताही एखादा कंपनीचा मॅन्युफॅक्चरर जो असतो तो हा चार्ट प्रिपेअर करतो की समजा मी 5 HP चं पंप करणार आहे आणि तुमच्या विहिरीमधला हा हेड समजा 120 मीटर आहे, तर 120 मीटरसाठी किती त्याचं डिस्चार्ज असणार आहे लीटर पर आवर or liter per second. So with the help of this chart, the chart will readily available from the manufacturer during the purchasing of that pump. Okay. So once we have that, we can select the pump for because we have the data. In this case, we have the data. The total discharge we required 5,000 liter per hour. Then we can bring that capacity of the pump from the market. Okay, and we have to install that depending upon the total head. Okay, depending upon the total head. So this total head and the required amount of water plays an important role for the selection of the pump. आता तुमचं एवढ्या वेळमध्ये हे काही तुमचं समजणं म्हणजे कठीण आहे, थोडंसं हार्ड आहे, बट इट विल रिक्वायर द थरो स्टडी. दिस इज द इंट्रोडक्शन पार्ट ओनली, and you will have such questions, but definitely you will get more idea whenever if you do the study with respect to the crop water requirement calculation, and I think this will be in your 3rd year, so you can learn more. But definitely At this stage, you only remember that there is a selection chart. We require the total demand and we require the total head. Once we have this data, we can select the HP. Okay. Anybody else? कोणाला अजून क्वेश्चन करायचे आहे? मंगेश. So thank you for your question. कोणी विचारलं होतं क्वेश्चन?